Hello, this is Carlos Herrera, and this is problem number 1 for the extra credit in exam 2. So, problem number 1 states, balance each reaction, draw a set of axes showing molar concentration versus time. Assume the reaction proceeds as far as possible to products, then plot the time of the time course of each species in the reaction. So here we have H2 plus O2 gives you the reaction of H2O. So the problem first states balance each reaction. So right here we just have to make sure that there is an equal amount for each. So there's 2 hydrogen atoms, 2 oxygen atoms in the reactants side, and over here there is 2 hydrogen atoms and 1 oxygen atom. So to balance this, I'm going to put a 2 over here. This will become 4 and this will become 2. From here on, we see that there's 2 oxygens, so that checks out. And over here we need to put a 2 in front also for it to become 4 hydrogens. So then the reaction is balanced now. So the problem next says draw a set of axes showing molar concentration versus time. So let's draw our axes. So the y is going to be your molar concentration. And your x is going to be time in seconds. What always helps me to do these problems is to set up a kind of like a ice chart. So you write the balanced equation down here. Initial change, and usually it stands for equilibrium, but let's just say equals. This stands for E. So the initial molar concentration they give you in the problem is 4 for hydrogen, 3 for oxygen, and since this is a product, these need to react to form this product, you have 0. So the change is going to be the stoichiometric coefficient. So right here it's going to be 4m minus 2, and then put a t for seconds for every interval. So then 3m minus 1, because there's only 1 for oxygen, T. And right here there's 2, so then you're gonna do, and since it's being produced, so you just have a 2 T positive. So let's go back to our chart over here. Since the highest molar concentration is going to be 4, you really don't have to go past it, but let's do 5. 4, 3, 2, 1. Let's do 1, 2, 3, 4, 5, 6. So let's start off with the hydrogen atom. So it initially starts at 4 molar concentration. So plot your point right here. And then 4 molar minus 2T and it's gonna be out second number 1. So it's gonna be from 4, it's gonna go down to 2. And then at 2 seconds, 4 minus 4 is going to be 0. So this is going to end right here. So you want to go like that. Make sure that it extends. H2 right there. Now for your oxygen, it starts off at 3 molar concentration. And right here, our change, right here we developed a little equation. It's 3 molar concentration minus 1 because of the 1 stoichiometric coefficient. And at 1 second, so it's just 3 minus 1, which is going to equal 2. And then at 2 seconds, since the hydrogen atom was your limiting reagent, you're just going to stop right here. But it's important to know that the oxygen atoms were not finished, so you're going to extend it all the way. It's going to go all the way like this, constant. And that's your O2. And lastly, your product H2O is going to start at 0 since it's a product. You didn't have anything to begin with. So then our equation states a positive 2 times the seconds. So then at second number 1, 2 times 1 right here, it's going to grow to 2 molarity concentration. And then at 2 seconds, remember that the hydrogen atom was the limiting reagent. So right here we're going to stop, and it's going to be at 4. But again, it's going to go constant all the way to the end. And that is your H2O. And that is how you solve this problem. Thank you.